Imagine your screen just goes completely black right before like a major presentation.
Ah, the worst nightmare.
Right. You panic, you submit an urgent IT ticket, and then nothing. You just get that cold, automated, "We have received your request" email.
Yeah, and then you just wait.
And for 3 agonizing days, your cry for help just bounces between, the database team, the hardware team, the network team, and all of them take one look at it and say, "Yeah, not my department."
Exactly. It goes straight into the dreaded IT black hole.
Exactly. And if you've ever worked at a modern office, you know exactly what that feels like. So today's deep dive is all about the bleeding edge technology that's designed to kill that black hole for good.
And we've got some really incredible material to go through today.
We do. We're pulling from this fascinating stack of technical sources. We've got research papers from the Yoshef Stefan Institute, platform architecture readmes, presentation slides from GFT, and detailed data excerpts from the HumAIne Smart Ticketing pilot.
It's definitely a dense set of materials. But, I mean, when you look closely, you realize we're basically looking at the foundational blueprints for how organizations are going to manage internal technical support for the next decade.
Yeah, it's huge. So our mission today is to unpack something called HumAIne, which stands for Humane Active Learning. We're going to explore how a specific framework, the human-in-the-loop model, is fundamentally flipping the script on how artificial intelligence is trained, trusted, and deployed in the workplace.
And we're going to focus heavily on how this approach saves just like massive amounts of human effort while making the AI's thought process completely transparent.
Right. But before we get to this human-in-the-loop solution, we kind of need to understand the baseline problem, right?
Yeah.
Like, why does that IT black hole even exist in the first place?
Well, the core issue facing IT support departments right now is sheer unmanageable volume. I mean, large enterprise networks generate thousands of support requests a week.
Thousands. That's just wild.
Right. And when a human coordination team has to manually read, interpret, and route every single one of those tickets, you instantly create a massive bottleneck.
Because humans get tired.
Exactly. That manual routing inevitably leads to fatigue, and fatigue leads to tickets being dispatched to the wrong teams. And in a large corporate ecosystem where, different vendors might handle different software components, a misrouted ticket doesn't just get handed back.
It just sits there.
Yeah, it sits idle in the wrong queue for days before someone even notices it's there.
Okay, let's unpack this. Because the obvious tech industry answer is, just throw AI at it. Let a machine read the tickets and sort them.
Yeah.
But our sources point out a massive flaw in using traditional machine learning for this specific problem.
Yeah, so the traditional fix would be a standard machine learning classification algorithm. You feed it the text of the ticket and it predicts the correct department. Simple enough, right?
In theory, sure.
But the roadblock is what that algorithm actually requires in order to learn how to do that. Traditional machine learning is just incredibly data hungry. It relies on supervised learning.
Which means it needs examples, right?
Right. It requires a massive, highly polished historical database of perfectly labeled examples before it can recognize even basic patterns. And compiling and labeling that much data is astonishingly expensive.
Right, because you're essentially asking highly paid IT professionals to stop fixing computers and spend weeks acting as, like, data entry clerks.
Exactly.
I think people hear machine learning and they assume it's just magic that figures things out on its own.
Oh, definitely.
But relying on traditional ML training is like trying to teach a toddler what a coffee mug is by forcing them to look at, like, 10,000 different photographs of mugs before letting them actually touch one.
That's a great way to put it. It's an exhausting brute force approach to learning.
Yeah. You're feeding the system thousands of easy, obvious examples like password reset, along with the hard ones, and making a human sit there and manually categorize all of them just to get the system off the ground.
It's highly inefficient. And the data from the HumAIne project deliverable puts a hard number on that inefficiency. When the researchers tested classical machine learning algorithms on this ticket classification problem, they tracked how much training it took to reach a respectable level of accuracy.
And what do they find?
It took around 80 training cycles just to reach a maximum F1 score of 0.8.
Okay, wait, let's clarify that metric for you, the listener. An F1 score is a way to measure an AI's accuracy that balances precision, meaning when it guesses the network team, is it right? And recall, meaning did it actually find all the network tickets it was supposed to?
Exactly, where a 1.0 would be flawless.
Right, so getting to point 8 is good.
Getting to point 8 is a solid, deployable metric for enterprise software. But taking 80 full cycles of training on massive human-labeled datasets to get there, That represents a huge, almost unjustifiable investment of human time.
Just to get a baseline tool working.
Yeah. And this data gluttony is exactly why the HumAIne Consortium realized they needed a drastically smarter approach for their smart ticketing pilot. They had to find a way to train the AI without forcing those ticketing experts to become full-time data labelers.
Which brings us to the actual solution. HumAIne introduces a paradigm called active learning. And this is where the system stops looking at 10,000 pictures of coffee mugs and starts actually studying smart.
Right. Instead of traditional random sampling where the system blindly grabs a massive batch of historical tickets and demands a human label every single one, HumAIne uses something called smart sample selection.
And this is the absolute core of the human-in-the-loop philosophy, isn't it?
It is. Active learning fundamentally changes the power dynamic between the human and the machine. The workflow, as outlined in the HumAIne architecture documents, is remarkably elegant. It starts with an IT expert uploading a very small partial dataset to the platform via a Minio API.
Wait, hold on. The documents say they start with as few as 50 anonymized historical tickets. I have to push back on that.
It sounds low, I know.
I mean, I've seen machine learning models that need millions of data points just to tell a hot dog from a hamburger. How can an initial dataset of just 50 tickets possibly be enough to map out the massive complexity of an enterprise IT system? That just sounds way too good to be true.
Well, you're right. On its own, 50 tickets wouldn't be nearly enough. But those 50 tickets just serve to initialize the model so it understands the basic shape of the problem.
Okay, so it's just a starting line.
Exactly. The system runs an initial training on those 50, but here is the mechanism that actually makes it work. As the system looks at a stream of new, unlabeled tickets, it doesn't just guess blindly. It uses specific mathematical strategies to calculate its own confidence.
Meaning it actually knows what it doesn't know.
That is the perfect way to phrase it. It uses strategies like uncertainty, margin, or entropy sampling. So imagine the AI looking at a ticket and analyzing the text. If the math tells the AI, I am 99% sure this goes to the database team, the AI just handles it autonomously.
It doesn't bother anyone.
Right. But if the AI looks at a ticket and the probability distribution is split, say, it's 51% sure it's a hardware issue and 49% sure it's a software bug, the system recognizes its own uncertainty. It knows it's confused.
Oh.
So instead of making a bad guess, it flags that specific, highly ambiguous ticket and surfaces it to the human IT expert for a label.
Okay, so if it gets a ticket that says, reset my password, the AI says, yeah, I've seen this 100 times, I don't need help.
Yeah.
But if it gets a ticket that says, the legacy mainframe API is throwing a null pointer exception only on Tuesdays when it rains, the AI essentially raises its hand and says, I have absolutely no idea what this is, and asks the human to break the tie.
Exactly. The human operator looks at that weird edge case ticket, tells the AI that it belongs to the legacy systems engineering team, and the model immediately retrains on that newly acquired, highly specific knowledge.
And then the cycle just continues.
Yes. The AI goes back to sorting, armed with a slightly better understanding of the boundaries between departments. And the impact of this targeted learning is just staggering. The documents show that this human-in-the-loop approach reduces the human labeling effort by 30% to 50% compared to traditional random sampling.
Because the human is never wasting time labeling the easy stuff. They are only spending their cognitive energy on the tickets that actually teach the machine something new.
Exactly. And because it's only learning from the most informative, boundary-pushing examples, the learning curve accelerates dramatically. You remember that classical ML took 80 cycles to hit an F1 score of 0.8?
Yeah.
The HumAIne system achieves that exact same 0.8 F1 score in as few as 30 training cycles.
Wow.
That's a 65% speed up in learning, and because the human is continuously in the loop, guiding it through the toughest cases, the performance doesn't just plateau there. It eventually pushes well above 0.85.
You know, here's where it gets really interesting to me. When we talk about AI in the workplace, the dominant, often fearful narrative is always about automation coming in to replace workers.
Oh, constantly.
But this framework flips that completely. Wait, so instead of replacing the human, this AI is essentially acting like a smart junior assistant who only taps the boss on the shoulder for the weirdest, most difficult edge cases.
What's fascinating here is that that's exactly the point. It elevates the human's role. The HumAIne deliverable explicitly states that this paradigm allows human teams to feed knowledge to the model gradually, preserving human oversight at every critical juncture.
It keeps them in the driver's seat.
It does, and crucially, it shifts the solution to a web-based interface. So ticketing experts who have zero technical expertise in machine learning algorithms can effectively transfer their decades of domain knowledge to the AI just by clicking a button on a screen.
That's brilliant.
They're doing their normal job routing complex tickets, and the AI is quietly learning from their expertise in the background.
But, that brings us to a massive hurdle. And anyone who has worked in enterprise tech will understand this immediately. Efficiency, speed-ups, and high F1 scores do not matter at all if the human operators don't actually trust the AI's recommendations.
Trust is everything.
Right. If a system just spits out a recommendation like route to database team with a 90% confidence score, but gives absolutely no explanation as to why it chose that department, it feels like a total black box.
And lack of trust is the single biggest barrier to AI adoption in these environments. If an IT operator is handed a tool that acts like an oracle giving answers without reasons, they're going to ignore the AI.
Yeah, they'll just double-check everything anyway.
Exactly. They'll just open the ticket and read the whole thing themselves to make sure it's right, which completely negates all the efficiency gains you just built. The HumAIne project recognized that a black box model would fail in a real-world pilot, which is why they integrated a layer of explainable AI, or XAI.
And the specific tool they used to break open that black box is called LIME, which stands for Local Interpretable Model Agnostic Explanations.
It's a very dense academic name.
It is. But the mechanism behind it is so brilliant. The platform features something called the HumAIne Glass Box Dashboard. When the AI makes a prediction about where a ticket should go, LIME literally highlights the specific words in the ticket's text that influence that prediction.
It breaks down the abstract mathematical weights of the neural network and visualizes the rationale in human language. LIME manipulates the input text-like, hiding certain words and seeing how the AI's prediction changes, to isolate exactly which terms drove the decision.
It reminds me of a strict math teacher in high school. You know the one.
Oh, absolutely. Show your work.
Yes, you write down the correct answer on the test, but the teacher gives you 0 points unless you show your work. LIME forces the AI to show its work. If a critical server outage ticket comes in and the AI routes it to the database team, the human operator doesn't have to just close their eyes and trust a blind confidence score.
Right.
They look at the Glassbox dashboard, and they see that the AI heavily weighted the words SQL, timeout, and query latency. The operator instantly verifies the logic, trusts the dispatch, and approves the action.
If we connect this to the bigger picture, this layer of transparency transforms the daily reality of the human operator. It supports ethical AI and compliance. They're no longer treated as passive data entry clerks, and they aren't expected to blindly follow the dictates of a machine.
They become high-level validators of AI logic.
Exactly. They maintain total operational control because they can actually see the gears turning inside the algorithm. If LIME highlights the word coffee as the reason a ticket was sent to the hardware team, maybe because someone spilled coffee on a keyboard, the operator can see that logic and agree with it, rather than thinking the AI is just hallucinating.
But, successfully dropping a ticket onto the right desk doesn't actually fix the user's broken laptop.
No, it does not.
Dispatching the ticket is really just step one. The black hole of routing is closed, but the clock on the actual problem is still ticking. How does the system actually help solve the ticket once it arrives in the right department?
Getting it to the right queue is only half the battle. And this is where the Joseph Stephan Institute paper details a completely different but complementary AI architecture. Retrieval Augmented Generation, or RAG, combined with a smart solver module.
RAG is a massive buzzword right now, but the way they're applying it here is very specific and mechanistic.
It's very targeted.
Yeah. They're using an OpenAI GPT model, but they aren't just opening up ChatGPT and asking it to guess the answer to an IT problem. They use something called sentence embeddings. Specifically, a model called All-MinLM L6v2.
Quite the mouthful.
I know, right? But what this does is convert the titles and descriptions of past, successfully resolved tickets into numbers. It creates 384-dimensional representations of the text.
A 384-dimensional space sounds like abstract science fiction. But practically what this means is that the AI is translating the underlying meaning and intent of a sentence into a specific physical coordinate in a vast mathematical space.
Let's visualize that for the listener for a second. Imagine a simple 3D graph, like you'd see in geometry class, with an X, Y, and Z axis. Now, break your brain a little bit and imagine a graph with 384 different axes.
It's hard to picture, but yeah.
When you use traditional keyword search, if you search for Apple, the system might bring up tickets about the fruit and tickets about the computer because it's just matching letters. But sentence embeddings map meaning.
Right.
Sentences that mean similar things end up physically clustered close to each other in that 384-dimensional space, even if they don't share any of the exact same words.
And that is the absolute power of semantic mapping. So when a brand new ticket comes in, the system translates the text of that new problem into coordinates. It then uses a FACE index, which stands for Facebook AI Similarity Search. Think of FIAS as a blazing fast navigation system for that 384-dimensional space. It searches the area immediately surrounding the new ticket's coordinates to find historically resolved tickets that are clustered right next to it. It's performing a semantic similarity search, finding past problems that share the same context and underlying issue.
And according to the research, this method works incredibly well. They achieve semantic similarity scores of 0.78 to 0.80 compared to responses written entirely by humans.
Which is incredibly high for this kind of automated retrieval.
But so what does this all mean? I have to ask the pointed question on behalf of the listener right now. We all hate getting an email from IT that says, "Have you tried turning it off and on again?" when we've just typed out a detailed paragraph about a specific error code.
Everyone hates that.
Right. How does pulling up an old ticket stop this from just feeling like another annoying robotic auto-reply to the person who submitted the issue?
That is the crucial distinction between a dumb macro and a retrieval augmented generation system. It does not just copy and paste an old response. The array system retrieves the historical context, the actual factual solution steps that worked in the past, and then it feeds that specific context into the language model.
Okay, so it's a two-step process.
Exactly. The language model then synthesizes that factual history into a freshly drafted first reply.
And the sources note that it uses keyword heuristics and regular expressions to detect what kind of response is needed. Right, like it classifies the need into 3 buckets.
Correct. It looks at the context to determine if it should draft a structured template response, a personalized conversational reply, or a global status update, like a system outage.
No, that makes sense.
If the heuristics determine it needs to be a personalized response, the model uses few-shot prompting, which basically means giving the AI a few examples of the desired output style to ensure the drafted reply is conversational, empathetic, and professional.
So it adapts to the stakes of the situation. If it detects words like system-wide or mainframe outage, it knows this is not the time to send a chatty, personalized troubleshooting guide.
Right. Instead, it drafts a formal incident communication outlining severity levels and expected resolution times. It drafts a highly accurate, contextually aware first reply that perfectly maintains the organization's communication standards.
Wow.
But again, anchoring everything back to the human-in-the-loop philosophy, this drafted response is not automatically emailed to the user. It is presented to the human IT agent in their dashboard.
Ah, so the human is still the final gatekeeper.
Always. This drastically reduces the time the agent spends staring at a blank screen, trying to write boilerplate text, or hunting through archaic, poorly organized company wikis for old solutions.
Yeah, that cuts out so much busy work.
The AI does the heavy lifting of gathering the facts and drafting the prose, but it keeps the human firmly in control to review, edit, and approve the draft before the frustrated user ever sees it.
It's just a complete overhaul of how a support desk operates. Let's distill this journey for you, the listener, because we have covered some incredibly dense ground today.
We definitely have.
We've explored how HumAIne combines the raw, massive processing power of modern machine learning and tethers it directly to the nuanced, hard-earned expertise of human IT operators.
It proves that the most efficient systems are true partnerships between biological and artificial intelligence.
We saw how using active learning and uncertainty sampling slashes the agonizing effort of data labeling by 30% to 50%. The AI learns faster by calculating its own confusion and only asking the human for help on the hardest, most ambiguous cases.
And achieving that 0.8 F1 score so much faster.
Right. And we looked at how explainable AI using the LIME framework shatters the black box by literally highlighting the AI's math word by word so human operators can actually trust the dispatching logic instead of fighting it.
Which is the key to adoption.
Exactly. And finally, we saw how the system moves beyond just sorting tickets. Using 384-dimensional sentence embeddings, AI's similarity searches, and MA to instantly draft accurate, customized first replies based on the organization's deep historical knowledge.
It addresses the entire life cycle of the IT support bottleneck, but it deliberately designs the architecture so that human judgment is never removed from the equation.
And why should you care about this? Whether you work in IT trying to keep your head above water in the sea of tickets, whether you manage a tech team trying to balance operational budgets, or whether you're simply someone who hates waiting days for a simple password reset.
Which is all of us.
Right. This deep dive proves something fundamental about the future of our digital lives. The future of work is not some dystopian scenario where AI replaces human workers. The future is a human-in-the-loop partnership. The AI handles the heavy lifting of sorting the mundane, retrieving the history, and drafting the boilerplate, so humans have the time and cognitive energy to focus on complex problem solving.
It's technology amplifying human capability rather than substituting it. When the machine handles the volume, the human can handle the nuance.
But I want to leave you with a final thought to mull over, building on everything we've unpacked today. We spent this entire deep dive talking about how the human teaches the AI.
Right.
The human labels the edge case tickets, the human corrects the routing mistakes, the human reviews and edits the drafted replies. But think about the long-term dynamic here. If the active learning system is constantly filtering out the easy, repetitive noise of a business and repeatedly surfacing only the most ambiguous, complex, and boundary-pushing edge cases directly to the human experts,
Oh, wow.
over time, could the AI actually end up training the human to see entirely new, hidden patterns in how their business operates? By clearing away the brush, the AI might just turn that black hole of IT support tickets into a telescope for the whole company. Something to think about.